So that's why Donald Duck doesn't wear pants. Pretty good. Hello there. Welcome back to another episode of Ion Physiology, where we're going to be talking about physio stuff. We're not going to be teaching the material again, but we're going to be reviewing it, hopefully in preparation for the exam to help you all out as you're going through this program. Hashtag UL Online Physiology Program. So, hi Amy, how you doing? Good. We got Amy right here. There you go. We got Dom right here. Haley right here. Nadeem, and I'm your host, Dr. B. All right, so this week we're going to jump right into it. What are we talking about, y'all? What are we talking about?
We are talking about some more topics with circulation.
So circulation, okay. So what did we go over last week?
Last week we discussed just to flow and like auto regulation, control, and just broad pictures when it comes to venous return curves and mean arterial pressure and learning how to navigate that whole chart that Dr. Harris is.
Good deal. Good. And so this week we are going to be talking about the second part of circulation, which is what? What do we start with?
We're looking more at like the control side of things.
Okay.
So we're gonna be starting with like
regulation,
smooth muscle control. Yeah.
All right. Well, it seems like you've got a grasp on it, Dom. Do you wanna take it away with the initial?
So with circulation, our vasculature is mostly modified by smooth muscle control, and so it's by neuronal control, hormonal control, and like local intrinsic control, which is by like local metabolism, metabolic factors that are released. And
so like neuronal, like when we think of neuronal control, what are we thinking of?
So that's the sympathetic nervous system.
Okay.
So there's no parasympathetic innervation for this smooth muscle.
Okay. So we're talking about the smooth muscle in the walls of the vessels, right? So when we think about this, the sympathetic nervous system is going to cause, you said there's no parasympathetic, so we're going to say it's going to cause vasoconstriction, right? Vasoconstriction, you would think, is going to restrict flow, right? Because when you constrict something in a single tube, it's going to decrease the diameter, which is going to increase resistance. So does it decrease flow?
So with flow, we have,
you've got a garden hose right here.
Yeah, it will actually restrict flow and
What's it going to do to pressure though?
It'll
increase pressure, and that's important because remember that when we are talking about the circulatory system, right, we're talking about everything. And what's really cool about these neurons is they're not going to just vasoconstrict the entire vasculature at the same time, right?
Yeah.
Some of it will actually be constricted and some of it will release or decrease its vasoconstriction, which causes vasodilation. So you're going to get vasodilation in some areas and vasoconstriction in another one, right? So oftentimes we see this in the phrases we say, or we've heard about, I'm sure you've heard about like rest and digest, right? Or fight or flight, right? It's not fight or fright. Some people will say fright. It's like you're going to be afraid whether you're fighting or you're running, right? But it's fight or flight.
Speak for yourself.
Yeah, maybe that's right. Maybe that's right. Yeah. So it's with rest and digest. You would think you get vasodilation where?
In the stomach, this flank, and base.
Right, GI tract.
GI tract.
GI tract, right? And you're gonna get blood shunting from the large muscles, essentially, these large muscle groups to the GI. Opposite happens when you are in a fight or flight, right? Is that you get shunting away from the digestive tract and into these larger muscles or these organ systems that are going to need it. So
this is a very good point, because a lot of people miss that on the exam, is that the brain, skeletal muscle, and the heart are controlled by the nutrients. The nutrients causes vasodilation or vasoconstriction. The more they need, the more work they need, the more the vessels will expand.
Level of metabolism.
The level of metabolism.
Yeah.
These are controlled by the level of metabolism. The other ones that are controlled by the neural is the skin, kidney, and splanchnic area, and they receive so much more blood than they need for different reasons, each one One, the kidney has to filter the blood. The skin actually controls the major role of the skin is basically temperature control for us. So it will get a lot more blood than it actually needs for nutrition.
In terms of the circulation,
Yes.
right? In terms of circulation, very good. So, okay, so that's neuronal, right? We said vasoconstriction, that's going to change resistance. Resistance is going to change pressure, whether we need to increase pressure or decrease pressure. And that increased pressure gradient is going to actually cause increased flow in certain areas, right? So you might be constricting it on this avenue right here, but that's going to cause increased pressure and increased flow on this other avenue.
So just like you said, I'm sorry.
No, go ahead. Yeah, yeah.
When you're running from a bear, you're not eating. The blood is gonna go away from like your stomach area into the muscles, the thighs or whatever that needs it to be running from the bear. Does that make sense?
And you know what they say about running from a bear, right? You don't have to outrun the bear.
You just have to outrun the person.
You just have to outrun the person next to you, right?
Yeah.
And you can substitute bear for any other animal.
No, you know why they actually say you should play dead when you see a bear?
Because they can outrun you 30 miles an hour.
No,
exactly.
because that's what you're gonna be in a minute.
Oh man, I don't know about that. That's a little morbid there, Nadine. That's a little morbid. A little more. We need our editing pod. We're gonna edit that part out. Right? I'm just kidding. You don't have to edit it out. It's fine. No, but it's a really important concept and thought, because if you've ever, what do they say before an event, before like an athletic event, what are you not supposed to do? You're not supposed to eat, right? They say don't eat a lot. Like maybe if you have to eat a snack or something light, right? Or something, something drinking. So fun story time with Dr. B. I trained for the 70.3 here in Louisville a year ago. And one of the things, I ended up not doing the 70.3 because I had a bike wreck and messed up basically took all the skin off the palm of my hands, had to let that heal. But I did the Olympic one, which is half of the 70.3. So it's a quarter of full Ironman. And one of the mistakes I made, and I didn't realize this until I did it, is that on the bike ride, they say that's when you want to hydrate and that's when you want to eat, right? Because you're using your legs a lot. Well, I ate like this protein, whatever, and it literally sat like a brick in my stomach because I just didn't have anything, because all of my circulation was shunted to the muscles, right? It's primarily the legs and the lung, the diaphragm and other stuff. And so next time I do it, I'm going to be doing, they have like these gel. Have you seen these gel packs that these football players and soccer players will go to the sideline and they'll like do, it's like a little straw. They'll just it's almost like honey. That's almost instant energy because it takes minimal digestion to get that into their system. So story time over, but that was an interesting case in point that I found out. So okay, so neuronal circulation. What else? You said
just different hormonal factors.
Hormonal. Okay, so like what? Like
that's where we have like angiotensin.
Okay.
And ADH, endothelin.
Angiotensin, right? So we're talking about what's the system called?
The RAS.
The RAS system. You all should know this, the RAS system. RAS, RAAS, right? A lot of times it can be referred to as RAS or RAAS. It's the renin, say it with me, angiotensin, aldosterone system, right? So you need to make sure that you know RAS backwards and forward. You better know your RAS, okay? Make sure you know it. Make sure you know. Well, let's talk through it real quick, just briefly, right?
Okay.
So how does it start? It starts with what?
Renin released from the kidney.
So renin does get released from the kidney, and renin is going to do what?
For angiotensinogen to angiotensin 1.
Very good. So where does angiotensinogen come from? Anybody?
Kidney.
Nope. Where does it come from?
Liver.
The liver. It's a protein, right?
Oh,
It comes from
Gosh.
It comes. Nadine, come on. So no, it comes from the liver, right? As do almost all of the blood proteins that we have, right? Released by the liver. So you've got angiotensinogen produced by the liver, and then renin from the kidney. Specifically, where does renin come from? Anybody remember where it comes from? I know this is not renal, but
That's the JG cell.
the JG cell. The JG stands for juxtaglomerular cells. And does anybody, bonus points, know what it's released in response to?
That would be decreased blood pressure.
Is it pressure or is it concentration?
Concentration.
Which one is it?
No, concentration.
Is it concentration of sodium or is it decreased pressure? Which one is it? Let's have a knockdown through.
Both.
I mean, I guess it would be, yeah. Well, due to the D.
Okay, so if you have a decrease in concentration of sodium, what's that gonna do to blood pressure?
Drop it. So
There you go. So, okay, so yeah, you could technically kind of say this, right? We haven't gotten to renal yet, have we?
No.
Okay, so we'll get to renal there. But anyway, renin is released, right? In response to what? And we said it's to look at what's the purpose of the RAS system? It's to do what? It's to raise blood pressure. Okay, so it's released in response to decreased blood pressure, which can be and is oftentimes caused by decreased sodium levels in the blood. So it's released, and Haley, you said it converts angiotensinogen into angiotensin 1. Okay, so now we've got angiotensin 1 floating around. What happens next to angiotensin 1?
it gets converted to angiotensin 2 by ACE, or
ACE.
angiotensin converting enzyme, which is released from the lungs.
Very good. So it's primarily found in the lungs. About 90 to 95% of ACE is found in the lungs. A small portion of it, though, is also found in endothelial cells, right? So endothelial cells are the cells that coat every single vessel in our body. So it makes sense. It's going to be released to the blood. It needs to be able to act in the blood without, going through the lungs, at least to some small degree. Okay, so then that releases, or not releases, but that creates what? Angiotensin, what was that? Two. All right. Angiotensin 2 has got a huge amount, like tons and tons and tons of different effects. Okay. But the four main effects that we want to make sure that we understand with angiotensin 2 are, what are they? Number one is it's a direct vasoconstrictor. Okay. Angiotensin 2 is a direct vasoconstrictor. Okay. The next one, what is the next one?
Releases ADH.
It releases ADH, which stands for anti-diuretic hormone. ADH is also called what?
AVP.
AVP, which stands for
Vasopressin.
arginine vasopressin. It's not BP, right? Arginine vasopressin, right? Where is arginine vasopressin or ADH released from? Posterior pituitary. It is one of two hormones. It's ADH and oxytocin are both released from the posterior pituitary. The rest are pretty much released from the anterior pituitary or other places, right? So that's the second one. We said direct vasoconstriction. It releases ADH, and ADH is going to act where? What is it going to do?
The kidney.
It's going to act on the
distal part of the kidney to actually sort
the distal. Is it the DCT or mainly I think it's the DCT and the collecting ducts. So it's essentially going to insert aquaporins in the collecting ducts, and aquaporins we know are going to allow for the reabsorption of water. If you reabsorb more water, you're going to increase the pressure and therefore resolve, basically bring blood pressure back to normal. Okay, so direct vasoconstriction releases ADH. What are the other two?
Aldosterone.
Aldosterone is what? Well, what's it categorized as? It's a
Potassium.
it's a mineral corticoid, right? So it's a mineral corticoid that, well, you're not wrong, right? So it's a mineral corticoid. I was fishing for that. I wasn't giving you guys good bait. My bad. So it's a mineral corticoid, right? Where is it produced?
The adrenal gland.
The adrenal gland. Specifically, where is it produced?
Zona glomerulosa.
Zona glomerulosa. The zona glomerulosa is the adrenal cortex, not the adrenal medulla. So the cortex has got three sort of zones, if you will. The outermost is the glomerulosa. The middle is the GFR, remember? Fasciculata, and then the innermost is the reticularis, right? So you can remember that by GFR because it sits right on the kidneys. You know what GFR, so GFR. You can also remember which one by this little fun ditty. I did not make this up. It was taught. It's called salt, sugar, sex. The deeper you go, the sweeter it gets, right? So there's a lot of different ways that you can memorize that or use mnemonic devices for retrieval of that information, right? So zona glomerulosa is the outermost. That's where aldosterone, the primary mineral corticoid in our body, is going to be created and released from, right? So what does aldosterone do?
Save sodium, lose potassium. That's how I wrote it.
Save sodium, lose potassium. And if you save sodium, what's going to happen to blood pressure?
Water.
Water will obligatorily be saved, and therefore, because remember, Water follows solute, okay? And so if you save salt or save sodium, right? Water's gonna follow that and it's going to increase blood volume. If you increase blood volume, you increase blood pressure, therefore resolving the blood pressure. Very good. Okay, so we've said it's a direct vasoconstrictor. It releases ADH, right? We're gonna save water directly. If you save water, you're gonna increase volume, increase pressure. We said aldosterone. If you save salt, that's going to save water obligatorily. And if you save water, you increase blood volume. And if you increase blood volume, you increase blood pressure. What is the last one? It's a sympathomimetic. What is a sympathomimetic?
Something that mimics the effects of sympathetic system.
Yeah, a sympathetic system agonist, right? So something that is going to stimulate the SNS, right? And that's exactly what it does. Now, once again, just a caveat, angiotensin 2 has other effects, right? It has many different effects. If you could draw little lightning bolts across, around Ang2, it's a very, very powerful hormone, right? So it's going to have other effects, but the four main effects, physiologically speaking, that at least in the scope of this course that we are concerned with, it's going to be we said it's a direct vasoconstrictor. It is going to release ADH, it's going to release aldosterone, and it's sympathomimetic. All of those are going to cause an increase in pressure, and that's going to resolve the pressure issues. Because once again, the RAS system is initiated when you have a dip in pressure and it's sensed by these JP cells. Okay, so that's the RAS system. Very good. So what else do we have? Wait,
I'm getting a word from our sponsor.
we do. We're just wait a minute. Let me see. Hold on.
Are you-
Oh, yes,
are you
yes,
hearing
okay. Studio producers are saying we need a word from our sponsor, so take it away. Haley.
that? So we know we've got Thanksgiving coming up and the holidays, whether you celebrate or not, everyone's excited for a break. So today, luckily, we're sponsored by Aunt Betty's Blood Pressure Bonanza. Today's show is sponsored by Aunt Betty's Blood Pressure Bonanza because nothing raises systemic vascular resistance faster than family holiday conversations.
I like that.
That's good.
That's a good one. I like it.
That's a good one.
I'm glad we paid that, right? That's
Yep,
That's a good one.
it wouldn't be possible without them. So make sure you have them next week.
right. Oh, wait, the sponsors are supposed to pay us, right? But we paid, yeah, okay, sorry. Wait we will pay you. Please join our sponsorship team here. We'll give you a crisp high five, right? All right, so Aunt Betty's blood pressure medication. I love it. So that's fantastic. Is that only one? We just have one. For now, okay, for now. Stay tuned. We don't have any commercial breaks to cut to, so producer is saying, let's continue on. So we're gonna go to Dom and talk to Dom about what's going on next.
So we talked about neuronal, hormonal, and last thing to talk about is the local.
Eat local, folks. Eat local.
control. Like Nadine was mentioning earlier. I don't know if you want to take it over.
Yeah, and there's a very good reason why you have local control and sympathetic control over something, basically for instance, if the brain is not controlled by the autonomic nervous system, and that's a very good reason. If you're running and then you get blood shunt away from your brain into somewhere else, what do you think that's going to happen? Like from your brain into the muscle, and that's why it's not controlled by that. But a very good, and actually is true, a very good thing that Dr. Harris always says that the brain is also when the areas of the brain is the flow of blood to the brain is always the same, but the areas of the brain that work more require more blood, and that's why they always tell us do not listen to loud music when you're studying, and it actually does work.
So what you're saying, for a layman's explanation of what you said, is that metabolically active tissue is going to receive more blood flow than tissue that is less metabolic.
And the brain as well. So
right, so the brain tissue. So and what is the main circulation of the brain that we talk, it's called something? Cerebral circulation, right? The cerebral circulation. So do you want to, looks like you had some fun facts there, Nadine. Do you want to tell us those fun facts, color coded?
Yeah, the brain receives about 15% of cardiac output.
15%, holy smokes.
And it's a lot, but that's the brain.
It's important.
It's always constant, it does not change, like again with exercise or whatever.
What about when you have a headache?
Depending on what type of headache, right? Like if you have a headache,
Still constant, even a headache? What do you guys
if
think?
you have a,
Everybody, anybody.
if you have, depending on what type of headache, that's what I understood, like.
Yeah.
If you have a tumor, for instance.
That's once again, we're going to the morbid.
I'm
Sorry about this,
Or if you have a brain.
Whoa there, Nadeem,
If
whoa.
you have a brain injury, it's probably gonna activate.
A traumatic brain, a TBI or a tumor.
And then.
Sorry, folks, we took maybe, I like this. What about just sneezing a couple times or,
Maybe it don't have to be something too much.
No, Nadeem is right. By and large, physiologically speaking, right, unless it's a pathological condition, it's gonna receive 15% regardless, right? Okay, so what's the next one? Brain flow is almost constant, and then overall brain flow is constant because, would you say, brain metabolism and oxygen demand are constant?
Yeah.
Okay.
It's not gonna, just think about it.
Yeah,
So the brain is never gonna give up its blood flow to help something else, because it needs it.
it needs it. There you go. There it is. Haley summed it up quite nicely. Very good. Okay. All right. So once again, we said we went over neuronal. We went over hormonal, some of it, right? Not all of it and not super in depth. Remember, we're not reteaching the material, we're just talking about it in a conversational manner. And then we said local, and we see this in other, pretty much in every system. We see this when we're talking about the respiratory system. We talk about exercise. The tissues that are metabolically active are going to receive the most blood flow due to local metabolites, right? We've seen this. We see that a local metabolite production, if it increases, that's going to cause a vasodilation, which will it'll decrease resistance and increase flow to these areas that need it the most.
Dr. Harris told us the story that a lot of people actually get a heart attack when it snows because they eat and then they go out shovel in the snow. And there's so much blood shunted away from everywhere into their stomach, and then the heart starts beating so fast, but still the blood is still in the stomach.
So eating right before you exercise is no bueno.
Exactly.
Right. So that's a good thing. We also see people that I believe there was a stat that did mention that a lot of heart attacks happen in the morning. And we'll have to fact check me on that one, but I think it's because there's a long rest, and typically individuals get a little bit dehydrated over nighttime, right? And so when they wake up, they don't hydrate right off the bat, and then and then they also get up. They're going from rest to exercise, so there's an increased afterload in cardiac load from heart. Did you Google it? Did you figure it out?
Yeah, you're right.
It is in the morning.
In the early morning hours.
In the early morning
Between
hours.
6
Yep.
a.m. and noon.
6 a.m. and noon, that's right. So once again, hydrate. We need this for the circulation, right? Make sure you're overly hydrating. And then also just a little fun thing, keep a thing of water by your bed at night, right? Have that there. If you don't, I've got a water bottle. Some nights I need it, some nights I don't need it, but it's always there. So, and if you can take just even a couple of sips or a big gulp right as you wake up, that's going to be not only good for your circulation, but it also help your digestion as well. It really helps lubricate. It also helps to sort of jumpstart and hydrate you as a whole. So very good. Okay, so what else is that pretty much it, or do we have anything else to talk about with circulation?
That's pretty much all we're talking about today. I do want to point out that GTAs we're hosting a town hall this Saturday morning. So
There
we're
you go.
going over some more topics, more detailed than what we would do here
Awesome.
in our podcast.
Do we have a time?
10 a.m.
10 a.m. this Saturday morning, so tune in.
Eastern time.
Eastern time, right? Plenty of time for the people on the Pacific Coast.
Yeah.
They'll have to wake up a little bit early. We'll have our coffee, and it'll be great. So 10 a.m. We'll be doing that this week. Hopefully, we'll get this podcast uploaded today. Let me know if you guys have any questions, comments, or snide remarks. And remember, we do this for you, right? We're going over stuff. If you're seeing these and you're like, I want to know about this, then leave a comment. Don't forget to like and subscribe, but leave a comment and or shoot us an email or send us a Teams message asking to go over a certain aspect of that. We'll include it in the podcast. And yeah, that's all. Anything else? Amy, I know you've been talking so much here. You should I'm trying to rein you in a little bit, but it's hard to rein her in, folks. It's hard to rein her in. So it's that sweater right there. Anyway, we hope you guys are having a great pre-holiday week. Don't forget your exam is opening up this Friday, and it will be open until the Monday,
December 2nd.
December 2nd, which is the Tuesday. It'll be open till Tuesday, December 2nd. So make sure you study. Circulation is not intuitive, but it is something that you are able to understand. You just got to put in the work, right? So make sure you put in the work, manage your time. If you need help doing that, reach out to all of us, any of us, myself. We're more than happy to help you guys. Okay? All right. And like I always end it, stay cool, stay in school, and don't do drugs. We'll see you next time. Bye.